Welcome to module 59 of Database Management Systems course in the IIT Madras online BSc program. In the last module, we stepped back and took a view of the RDBMS with reference to performance and scalability. That what we have designed is something which is good, robust in an RDBMS, but will it scale? Will it continue to perform at the same level? And in this connection, we took a quick tour of different system and database architecture and kind of came to the conclusion that it is a database distributed architecture. That is what we have to adhere to if we are really going for scaling high and high, and possibly scale out, that is horizontal scaling is what will be the option that we will have to mostly go with. So, with that background, now I talk about something little more recent developments, that is to understand the issues in big data. You all have heard about big data, I am sure. And based on that, we will try to just take a quick look at the approach of what is called NoSQL and assess the CAP theorem vis-a-vis ACID, and take a quick tour of common types of NoSQL databases. So, this is all that we discuss here. So, what is big data? Big data, as the name suggests, is big. It's bigger than, much bigger than what we can conceive. So, this graph, which itself is pretty old because it was published in 2011, so more than 10 years old. You can see the basic trend, that how the data volume in the world is increasing. And it also shows the division between analog storage and digital storage. So, you can see that while the analog storage is more or less remaining the same after the initial growth and is in fact possibly slowly reducing, the digital storage is the main explosion that is happening. So, this is the 80s where analog storage used to dominate. Then we have introduction of lot of different digital storages in the early 90s, and in 2002 it is typically called the beginning of the digital age, where the analog and the digital storage started balancing and then exploding. You can see what is the explosion that is going on. And now with reference to 2011, the estimate was there is 19 exabyte. What is exa? You have mega is 10 to the power 6, giga is 10 to the power 9. This is then you have peta, then you have exa. So, you have hugely large of this, which is 19 exabytes, which mean analog means the paper copies, the microfiche, film and all that analog device, recording devices. In contrast, the data digitally was estimated to be nearly 300 exabytes in all different digital forms, and with the mobile devices, handheld devices is exploding like anything. So, this is the basic first paradigm of big data, which is a data set is so voluminous and complex that traditional data processing applications are no more adequate to deal with them. And there are several challenges that exist, like how you capture the data, how you store that data, forget about any centralized store, even a simple distributed store. How do you analyze the data, visualize the data, how do you query that data, and so on and so forth. I mean, even a single social media application like Facebook is a humongous big data problem, right. And big data also is not just data which is big, but it refers to different kind of novel analysis like predictive analysis, user behavior analysis. Amazon knows really what you are going to buy in the next 1 month, has a fair estimate of that without you knowing it actually clearly. So, these are things that big data is leading us to. So, there are certain characteristics of big data. Naturally, volume is the first, variety is next, that is the type and nature of data is widely varied, text, image, audio, video, everything. The velocity, the speed at which the data is generated and processed is increasing enormously. Variability, that is the inconsistency of data sets can hamper, you can no more assume that the data is all consistent. There will be a lot of input data which are not consistent. The veracity, the quality of captured data can vary greatly. Some data are very accurate, some are of very low accuracy and so on. So, these 5 together, all starting with V, is known as the 5 V's or characteristics of big data. Right? So, the challenge here basically is how do you deal with applications, database systems which will deal with such big data. So, NoSQL is a kind of mechanism. It is not a particular database system, it is a kind of mechanism for storage and retrieval of data, which is what was the objective of relational as well. That is modeled in means other than tabular relations used in relational database. So, you try to model them differently. Tabular relations do not cater to easy management or feasible management of such scales of data in terms of storage and retrieval. Right? So, in the last module, if you recall, when I started talking about the performance and scalability of RDBMS, I talked about alternate models. So, these are the alternate models that we are talking about in NoSQL. Now, this is not a surprise, because you are having big data and you are having real time web application, web 2.0, you need all of that. And interesting thing is, actually all this started long ago, almost actually before the relational data models came in. So, you had hierarchical data model, which was the first formally accepted data model from IBM in the 1960s, and network data model. So, hierarchical is a tree kind of a structure, and which links the data records one to the other. And network is more like a graph kind of a model. So, it's the schema is viewed as graph of objects and their nodes. Right? And these two came in early 70s, and both of them actually survived actively till relational databases, which came in later part of the 70s, started dominating the whole field. But now these, or basically evolutions of these, are making a comeback in terms of the NoSQL. So, what does NoSQL means? NoSQL is not no to SQL. NoSQL is just too powerful. It is just too useful for several enterprise applications. It stands for not only SQL. So, it is a lot more than that. So, this coinage came strongly in the 21st century. It was first used by Carl Strozzi in 1998, but then it was reintroduced by Eric Evans, who did a lot of work on NoSQL, and that has become a term for these kind of databases. Now, there are several advantages, comparative advantages and disadvantages with respect to the relational. It is not relational. It does not require a schema to be frozen beforehand. Data is replicated to multiple sites. In relational, you will remember how strongly we fought to reduce redundancy. You do not do that, you do it differently. And the data can be partitioned. If a node is down, it can be easily replaced. There is no single point of failure. It is horizontally scalable, scale out we talked of. It is cheap, easy to implement, massive performance in write, first key value access and so on. In comparison, you have all the known properties of RDBMS, which do not compare to them, like the disadvantages of NoSQL will lead to the fact that you do not have a declarative programming language. So, you need to do more of programming. The ACID is compromised, because otherwise you cannot work with the 5 V's. It does not support the relational features fully, maybe partially. There is no easy integration process and so on, and we will see through some of these in the later part. So, I am talking about some of the well known common popular non-SQL databases are Cassandra, MongoDB, your HBase, Dynamo, all of that. And this is just a glimpse of what some of our leading companies are using. I mean, web application, Web 2.0 companies are using. So, you can see the Facebook, which uses Cassandra, Twitter also uses that, Reddit also uses that, your Google use their own big table, which is one of the initial points of NoSQL. Amazon uses their own Dynamo, and LinkedIn use this particular NoSQL database, and so on. I mean, there could be several. I just wanted to give you a glimpse of where we are in terms of this. So, as it is called, that how did NoSQL happen? So, it is called the perfect storm. That is something which changed a lot of things to support large data sets, accept alternatives. Right? Do not be so rigid mathematically and otherwise as you are in the relational, and accept dynamically typed data. These three concepts came together to create a perfect storm in the world of web applications, in the world of database application. It has to be remembered that this is not a backlash against RDBMS. The question is not that RDBMS is no more useful. It is. For example, you are doing a net banking transaction on net, you will not use a NoSQL because of the compromised guarantees that NoSQL databases will normally have. SQL is a rich query language, and it cannot be rivaled by any of the current NoSQL offerings, but it is a different space of big data, it is a different space of Web 2.0 applications where you need this kind of new database models. So, it all started in around 2006 to 2010, that time period. So, it is about 12-15 years back, is when there were three pioneering papers, one by Google called Big Table, one by Amazon called Amazon's Dynamo, and one by Eric Brewer, the CAP theorem, which we will study. And it came with a lot of interesting concepts that after the CAP theorem, some of them I will just to briefly talk about, that is gossip protocol and the eventual consistency concept. So, let us see what the CAP theorem talks about. CAP theorem is kind of the equivalent of ACID in terms of the NoSQL. So, C stands for consistency, that this data is heavily replicated, all copies have the same value is what you want to achieve. The A is for availability, that is read and write always succeed, that is each client always can read and write, that should happen. And its partition tolerance, that is a system can continue to operate in the presence of network partition, the database being divided. So, these three properties together is known as the CAP theorem. Now, known as CAP, the CAP theorem says, this is very, very interesting, that for any system sharing data, it is impossible to guarantee simultaneously all of the three properties. You cannot have all of them together. You can have only two at a point. Now, so why is it called a theorem? There is no proof for that, but there is no counter example either. Right. So, this is more like it is called a theorem, but it is more like a realization, more like a principle. So, since you are talking about very large systems, they will partition at some point of time. You cannot easily live with systems which will not partition. So, that will leave you with the choice of which of the two between C or A you will choose from. Now, if we talk about traditional databases, then we prefer C, that is, well, at some points the availability may be low, the system may be busy not allowing me to access, the partition may not be possible, but consistency will have to be there. Now, here in many cases we choose A over C, that is availability over consistency. Of course, not in such applications. So, they will go into RDBMS, they will not come for NoSQL. Right. So, what does this consistency means? Consistency says that all clients always have the same view of the data. Now, where it differs from what is studied in the RDBMS is that RDBMS follows a strong consistency, the acid properties, atomicity, consistency, isolation, durability, you know it very well. Whereas, now we are talking about a weak consistency, which is nicely acronymed as BASE. Basically available soft state eventual consistency. Basically available, so availability is the first thing. Soft state, that is not very hard and fast, and it will be eventually consistent, not every time consistent. Right? So, given this, let us look at an example to understand what we mean by this consistency. So, the consistency model determines the rules of visibility and the order of updates. Remember, there are multiple nodes in the system which hold the data, and they may be weakly connected, not they are eventually connected, they are necessarily connected, but all may not be connected to everyone else, because that is not possible. So, when we say row x is replicated on nodes m and n, these two nodes. So, client A, so row x is available on nodes m and n. So, client A writes row x to node n here. So, after some point of time, so what will happen? The client A is written to node n. So, it will be available at node n what the client has written, but not on node m. After some period of time t elapses, some random period of time t, the client B reads x from node m. Right. The question is, does client B see what was written by A? The consistency is a continuum with trade off. In relational model, you will say that of course, otherwise the data is inconsistent. Here it is not. In SQL, the answer is maybe. Maybe if node n has been updated on node m, otherwise not. So, what you do is, instead of trying to, I am sorry, I erased this. Instead of updating all these nodes at the same point, if this is updated, then you follow, I am just very at a top level I am just trying to give you the philosophy. What you do a gossip, that is node n after a random amount of time updates this data on a random set of nodes, say so. At this point, if some client reads the data from n, p or q, it will get the updated data. Someone reads from m or r, gets a not updated data, it is maybe, but the gossip continues. So, after a random amount of time q, let us have some more. This is x, this is y, this is z, this is w. After some time, random time, q updates the data on some nodes randomly, maybe tries to update on p also. After some time, p updates on x. After some time, w updates on r and updates on m. After some random time, x updates on y. So, the process is very simple. It is the way the gossip, why is it called a gossip protocol? Because it is the way the gossip propagates, that you hear something, you randomly tell few of your friends, you do not tell everybody, few of your friends randomly tell their friends, some of them randomly tell their friends, then eventually over a period of time all your friends get to know that gossip. So, it is that same kind of a protocol. Of course, there is balancing of how much random delay you give between the gossip cycles, how many nodes randomly you send this write to, but over a certain period, if no updates occur for a long period of time, eventually all updates will propagate through the system and all nodes will be consistent. This is the concept of eventual consistency. That is what the gossip protocol supports, and that is what is the basis of the base properties in contrast to the acid properties. And this relaxation makes the feasibility of NoSQL systems much better. Here again some examples for you to appreciate that what is the consequence of Cap's theorem, that at most two can be simultaneously guaranteed. So, for example, Cassandra and Dynamo, these prefer partition and availability, which is absolutely understandable, and therefore, you have certain inconsistency, eventual consistency rather in the system. Whereas, Big Table, Hypertable, MongoDB, they prefer consistency and partition. So, availability may be low, and there is RDBMS particularly, which do not consider partition, that is not the priority, but the priority is availability and consistency, the acid properties, but there are several. So, this side primarily CA gives you the acid and leads you to the relational database systems primarily and other database systems which has a similar property. Not every database system, every non-NoSQL database system is also relational, but most of the NoSQL systems fall under AP or CP categories. Right. So, that is the beauty of the whole system. Right. Okay. So, let me just quickly, this will be just a quick, this is not for you to really understand every bit or remember every bit, but just to give you a quick view that NoSQL, as I said, is not one model now, not like relational. There are key value stores which keep key value pair, there are databases, NoSQL databases which primarily store documents, some are organized in terms of columns and super columns, and some work primarily on graphs. So, what is common between all of them? These are the four dominant types of NoSQL databases that you have today. The dominant common property is none of them have a schema. It evolves as the data comes into the system. So, there is a paradigm shift from what we were doing in the relational database, when we had first analyzed and thought about the schema set. The schema is frozen in stone, you cannot change that once your database has data in it, but here you do the reverse, you say there is no schema, the schema will keep on evolving as the data comes. So, it is a common characteristic of most NoSQL storage system. So, it provides very flexible set of data types, even the data types can be increased in the life of the system, very different kind of. So, quick look into a few, for example, key value store focus on scaling to huge amounts of data, can take handle massive load, Amazon's Dynamo, based on the Amazon's Dynamo paper, DynamoDB, right. So, items have one or more attributes, simple. Attributes can be single valued or multiple valued, items are combined into tables, right, but they are not relational, they do not go through all those constraints and all those dependencies and all of that, but it is basically key value pair. So, the basic APIs will have get a key, extract the value given a key, put a key that is write, delete a key, this is remove, or execute if there could be operations associated with these nodes, and you can execute them, like you can list, map, this kind of. So, it is very fast, very scalable, simple data model, eventually consistent, fault tolerant, but it cannot model more complex data structure like objects, because you are having a key value pair only, right. So, many use the this kind of key value stores as stores NoSQL database when these requirements are primary and complex data is not a primary case. So, these are some of the examples. I will not run through the basic properties, but I have given the name, the producer of who actually produces that database, what is the kind of data model that eventually gets used, and what is the different querying that exists. The second is document store, which tries to keep everything as if it is a document. The data is as if it is a document, right. This was again inspired by a very old model called Lotus Notes, which used to be there possibly in 80s. And as a document, it can certainly model more complex objects, and it is a collection of documents. So, it can be it can use XML or some semi structured format, it can use JSON, and an example would be like this, that you write name. So, you can you had learnt about XML tag and value pairs. So, it is very similar. So, name is this, address is this, grandchildren. Now, you are getting hierarchical because you can have multiple values on this each one, then multi-valued attributes like phone and so on. So, all these can be very easily stored in terms of document store structure. This is the basic structure of how it should be written. So, it starts with a curly brace, you have a string, colon value, which is the tag name. You can have multiple of them separated by comma, and you end with again a closing brace. You can have array, you can have different types of values. So, that is a document store NDB. MongoDB, Couchbase, both are very popular, are the two different at least two of the dominant document store non-SQL, NoSQL database system. The third type is column store, which is based on the big table paper of Google. So, it is like it is column oriented like RDBMS, but it is a twist that it is the handling is semi structured. So, what you have is not a table with pre-decided set of columns. The columns go into collection of column families. A column family is a key value pair, and related set of columns can be built into super columns, columns of columns, right, hierarchical in a different way. It is indexed by row key, column key, and timestamp of where you have written. This timestamp is very important. You will recall we have used timestamping in some of the protocols with reference to deadlock. Here the timestamp would be important to guarantee eventual consistency. So, one column family can have variable number of columns, and cells within the column family are sorted physically. So, this is typically how the data will look, and you say this is these are the different entries in that. These are actually the columns, the age, gender, email address, but they are all flexible. You do not need to have all the column values for every item that you have. So, these are some of the NoSQL database that support column store, Big Table of Google and Cassandra of Apache. Originally Facebook had developed it, which are very popular. Hypertable also is quite popular. Finally, you have graph store, which basically tries to keep data as a graph. So, the data model is a property graph, nodes and edges. Nodes may have a number of properties, and edges may have labels or roles. So, kind of you can see that this is probably an extension of an ER model that we have seen, but the context is simply very different. The interface and the query languages vary across the graph structure. It may have single step or path compression, full recursion, because you have to naturally, since a graph, you will have to traverse the graph to answer a query. Right? So, these are some of the graph databases that you have. Now, finally, before we conclude, let us summarize by taking a look into what did we achieve by getting non-relational or getting into NoSQL. We have, in terms of flexibility of data model, relational works only on structured data, non-relational can handle unstructured, semi-structured data, along with dynamic modification of schema, which are very suited for big data. The cost, complexity and speed, relational of course is faster for less capable, less complex operation, cheaper but less complex. But non-relational, NoSQL is much more database operations are supported, highly complex internally and is costlier of course. Performance and scalability, we have seen specifically that it incurs issues, data integrity needs to be maintained at all levels. So, getting to a case of distributed architecture was a problem, and NoSQL has better scalability, performance, and by changing from ACID to base kind of expectation. Consistency is enforced everywhere in relational, eventual consistency is what you look for in non-relational. Enterprise management and integration would primarily be relational because it fits into the enterprise's IT stack, but non-relational is designed to cope with ability to agility to manage modern cloud-based applications, Web 2.0 and onwards. So, that was what I wanted to give you a glimpse of what is happening in the database spaces in the recent times in the last about 1 to 2 decades. So, we have talked about big data, NoSQL, the differences that NoSQL is designed with, and discussed 4 common types of NoSQL database systems. Thank you all very much for your attention, and we will meet in the next module, the concluding module of the course.